Alright, this video is on neutralization reactions. A neutralization reaction is, as you read in the book, a combination of an acid with a base to form water and some sort of salt or ionic compound. Okay, so there's a couple different skills that I'm going to have you guys do. One is just ionization of an acid or a base, and then of course I want you to write out the balanced equation for a neutralization reaction. So the first thing we'll do is going to be to ionize, which if I was to take hydrochloric acid, okay, and this being aqueous, I would break it apart into the H plus ion and the chloride ion. Okay? Now this ionization reaction of the hydrochloric acid breaking apart obviously needs to be balanced both in the number of atoms. So I have one hydrogen here, one hydrogen here, one hydrogen here. I have one chlorine here, one chlorine here. And of course, when I look, I have no charge here. I have one positive and one negative. Of course, that wouldn't be a negative. One negative coming together to make something neutral, or in this case, something neutral breaking apart into something that has charges. Okay? So, an example of a base being ionized. Let's go with sodium hydroxide. Okay. Now the nomenclature is pretty easy for the bases. Okay. This is OH is hydroxide, so usually it's a metal with a hydroxide. It's beryllium hydroxide, lithium hydroxide, iron hydroxide, aluminum hydroxide, potassium hydroxide. All of those are all bases, and it's pretty simple. All you're going to do is, just like we did with the acid, you're going to break it up into the cation and the anion. Okay? And just so we saw before, we have a neutral charge, a positive charge, a negative charge, so that's balanced. We have one sodium and one sodium. And then, of course, we have one hydroxide and one hydroxide on both sides. Okay? So, a couple little practice problems for you. Okay, so we have nitric acid, which is going to be, it's an acid, obviously, since it's nitric acid, but usually what you're doing to identify if it's an acid or a base is the presence of hydroxide. Okay? If it has an OH in it, it's most likely a base. All right? If it has a hydrogen, either most likely up front, like the HNO3, okay, or you look further down with the H2SO4, okay, those would both be considered acids. And of course, the KOH and the calcium hydroxide, or Ca and then OH2, those are bases because they have the hydroxide. So with nitric acid, I'm going to have my hydrogen ion, and that's going to, form ionize into hydrogen and the nitrate ion. Okay, I have one nitrate on both sides. I have one hydrogen on both sides. We're good, and my charges are going to balance out. Potassium hydroxide, potassium plus, plus OH minus. Okay, there's my hydroxide that's been ionized. Okay, and then when it comes to something like sulfuric acid, okay, which is H2SO4, this is what we call a diprotic acid. Di meaning two, and protic is referring to the number of hydrogen. Okay, so if I have H2SO4 or anything that's H2 and it's an acid, that's a diprotic acid. So if you look, I'm gonna first thing I'm gonna go H plus, and then I'm going to have an SO4, and if I look at my you can look at your solubility rules as well. But if you look at your polyatomic ions, you know sulfate is a negative 1 or negative 2 charge. So looking at that, I need to balance the equation. Well, I have two hydrogen on one side, I have one on the other, so I need to make sure that I put a 2 right there, because that'll also, in addition to balancing out my hydrogen atoms, it'll also balance out the charges, because this H2SO4 is neutral, and then now I have 2 pluses over with the hydrogen, because each hydrogen has 1 plus, and I have 2 of them, and then H sulfate has a -2 charge. All right. With the calcium hydroxide, same idea. I'm going to break calcium up. Okay, now calcium is a 2 plus according to the periodic table, right? And I have hydroxides OH minus, because I know it's a base. Now, if you look, it's not balanced because I have the correct number of calciums, but I do not have the correct number of hydroxides. On the product side, I only have 1 hydroxide, and on the reactant side, I only have 2 hydroxides. In addition to the hydroxides being unbalanced, hopefully we realize that the charge is also being imbalanced, because on my reactant side I have a neutral compound, and the charges on my product side should equal 0. And right here, as they are, they don't. They equal +1. So if I put a 2 right here, and that coefficient in front of the hydroxide, that's going to kill 2 birds with 1 stone. It's going to give me my 2 hydroxides, but it's also going to give me the additional negative charge to balance out my that side, so it's 0. Okay. Now let's take a look at a neutralization reaction. Okay, let's go ahead and say between nitric acid and potassium hydroxide. Okay, so I'm going to have HNO3, which is aqueous, plus KOH, which is also aqueous. Okay, I have an acid and a base right here, which means my product is going to be a salt and water. So automatically, I'm just going to go ahead and put my water, which will be a liquid. Okay, and then I will have a salt, an ionic compound. Well, let's take a look. If I was to, now you don't necessarily have to do this when you're doing your neutralization reactions, but if it helps you, then by all means do so. Okay, if I was to take out the hydroxide and take out the hydrogen, I end up with a potassium and a nitrate. Well, potassium is positively charged, nitrate is negatively charged. In fact, they're +1 and -1 respectively. So when I can actually write it out as KNO3. Okay, and that would be aqueous because potassium nitrate is soluble. Okay, so my overall reaction is going to be HNO3 aqueous plus KOH aqueous, forming H2O liquid plus KNO3 so potassium nitrate aqueous. All right. Now, of course, if I was to want to write a net ionic equation for this, I could, but I'm not going to require that of you right now. Okay, but remember, you would follow the same rules. If I want to write a net ionic equation, I would ionize this. I would ionize this. This is not something I can ionize. I would ionize that, and then I'd cancel out my spectator ions. Okay, so that's not what tomorrow's worksheet's about, but you guys use the logic you guys did last week and figure it out. Okay, aqueous things can be ionized, right? So move on to the next one, and let's go ahead and do the sulfuric acid and the calcium hydroxide. So sulfuric acid, H2SO4, which is aqueous, plus calcium hydroxide, okay, which is aqueous, right? Look at our rules. And that is going to form water, which is a liquid, plus, you got to think, when I get rid of my hydroxide, to get rid of my hydrogen, I'm going to end up with calcium sulfate, which would be CaSO4, and in this case, it would be calcium sulfate would be a solid. Okay, so once you've written that out, now of course we got to make sure we balance it. Okay, looking here, I have 2 hydrogens over here. I have 2 hydrogens over here. Okay, on my acid, and I have 2 hydrogens in my water. But remember, I have 2 hydrogens here as well. They're part of the hydroxide. Okay, So if you look, I'm going to have 4 hydrogens, and I have 2 oxygens. Well, I need to get 4 hydrogens and 2 oxygens on the product side. Well, if I put a 2 right there, then that should balance it out for me. Okay, another way to do this and make it really quite simple is you look at the number of hydroxides and the number of um, hydrogens that are on the acid and the hydroxides that are on the base, and that's going to give you a hint as to how many waters you're going to make. Okay, so for example, if I had, say, H3 whatever, okay, let's go ahead and say H3A since it's an acid, and then I have some sort of metal, let's go say metal with OH3. That means I have 3 hydroxides here. I have 3 hydrogens here. That means I'm going to make 3 waters. Okay? Now, what can be tricky, you just got to make sure you keep your numbers intact, and that's when you're going to end up having more than just a coefficient on one species, is when I have something like H2A plus metal hydroxide 3. Okay? So in this case, I'm going to have 3 hydroxides and I have 2 hydrogens. Well, what you can do is you can just go ahead and, if I work everything out, I would go 6 waters. Okay, because it's the lowest common multiple between, or it's the lowest common multiple between the 2 of them. Okay, so if I go 6 waters, then what you need to do is make sure that I would need, of course, if I had 6 oxygen or 6 waters, that means I would need 2 of those and I would need 3 of these. Okay, and when I do that, you need to make sure that you, when you balance your equation, make sure there's 2 of your metals on the product side, and there's 2 of your non-metals or your the rest of your acid on the other side. Okay, so that's neutralization reactions. Okay, again, making sure, and very important, that you put in your states when you do your, so you look at your solubility rules to make sure you're doing it right. It's also good practice for those solubility rules. Worksheet will be due tomorrow in class.